the end, we can confirm the solution. Okay. So today we're gonna stick with decision tree in the morning. So we're gonna bring Bayes' theory into the picture, and then depending how long it takes, okay, and then we're gonna do the forecasting in the afternoon, probably, or maybe in the morning. We see how it turns out. Okay. So before we get to that, okay, there's one more expected value that we have to compute. Okay, this is one is called expected value of sample information. So this one want to know it's just like when you do the EVDI, all right, same thing. Okay, we just change it from perfect to sample information. All right, it follows pretty much the same concept. All right. So this is the actual of doing the survey. All right. So EVSI will be equal to expect value with sample information, assuming that you don't have to pay anything. Subtract the expect value of best decision without sample information. So basically the solution is going to be equal to if you go back to that, it's going to be your last expect value right here when you do the survey, 49,200, all right, plus the cost of the survey. All right. So that expected value, if you do survey, or basically with sample information, plus the cost of doing the survey. And then you expect that you subtract that from the expected value without sample information, or that's 40,000. Okay. So when you go back to that decision tree, basically the answer is going to be equal to this number, okay, expected value with sample information. So it's going to be this number plus the cost of the survey. So the cost of the survey is equal to 10,000. So this number plus 10,000, right? And then subtract this number. Subtract the. I cannot highlight it. Okay, but basically this number. Okay, this is expected value without sample information. All right. So again, if this is going to be equal to, you look at the part when you do the survey, not the maximum one. Okay. You don't care about this maximum EMV. Okay. You look at this part. You look at what the highest number, or not the highest number, what is that expected value, 49,200, plus the cost of doing the survey, 10,000, and then subtract it from the expected value without sample information. Right, so that's how it's done. Right, so it shouldn't be that difficult to compute. So when you look at the decision tree, it's easier to, I use this number plus the cost survey and then subtract that number. Compared to if you have to, this is what each term really means. So that's equal to 19,200. Right, so that's the actual value of that survey. Right, so if you compare that number with this cost of survey, you're going to say, then we're not doing too bad because the actual cost of survey is the value is almost 20,000, but you only pay 10,000, so you're okay, right? So you're not doing a bad job, so you're okay, right? Because this number is higher than the cost of the survey. Any questions? No. All right. Move on. Let's see. This is sensitivity analysis. Okay. For this problem, we can also do the sensitivity analysis. All right. But it's going to be the one on the probability of the result of the survey. Okay. So right now, this is what we have. Right now, the probability of favorable result is equal to p equal to 0.445, right? So this one is fixed right now, okay? The question is, okay, if somehow this P is a different number, okay, would we make the same decision? So we go back to that decision tree. Okay, basically we focus on this number. Okay, let me highlight it. All right, we're focusing on this number, 0.45. We don't care about this number. Okay, this probability, we're not going to do any sensitive analysis on this number. It's going to be on this number, 0.45. Okay. And we know that the maximum EMV of the positive result is this number, 106400. And for the negative result is this number. Alright, so that's the equation that we're going to use. And we compare that against 40,000. Alright. Because right now this 49,200 is greater than 40,000. That's why we say, hey, let's do the survey. But we want to find out, okay, if this probability change, okay, when are we going to switch to, nah, I'm not going to do the survey. It's not worth it. Alright, so when that's going to happen. Alright, so let's look at the equation. Okay, so the equation is going to be equal to the EMV on that node. It's going to be 106,400. Alright, multiplied by P. It used to be 0.45. Now we replace it with a decision variable P. Plus 2400 multiplied by 1 minus P. Right? So we got this after you do the algebra. Then you set this equal to 40,000. We don't set it to 0. That's not what we want. But compare with 40,000. Because that's going to be the number when we switch to, we're not going to do the survey. Alright, so after we solve everything, that P will be equal to 0.36. Right, so it means that as long as, okay, P is greater than or equal to this number, you will do the survey. Okay, you will do the survey. You will switch to another decision only when this P is less than 0.36. Okay, so for my handwriting, that's the best I could do with the mouse. Okay, so again, as long as P is at least 0.36, you will do the survey. But when this P is less than 0.36, your E will be less than 40,000. That's why you will say, why bother with the survey? Alright, so that should be okay. So next part is going to be the one that is going to be the most confusing. What do I mean? So next, I'm going to explain to you when this probability is not given. Right? So let's say that I don't give this probability to you directly. So it's not given to you. So it means that you have to figure this out. Alright, so I'm just explain, okay, and then I'll give one example for you to do for practice. Because you need practice because there are two options, okay, in the midterm, okay. I might or might not give this to you, but considering that the midterm we only cover probability, decision tree, and forecasting, okay, I can tell you in advance that it's highly that you will have to compute the base probability for this problem, okay, because there's not many problems that I can give you, okay, because we only have 3 weeks and then the midterm. So that's a big hint, okay? You should be able to guess my mind. If not, then I know whatever way to say this, okay? So make sure you pay attention to this. Okay, so let's take a look. Right. So as we know from 2 weeks ago, okay, when we do Bayesian probability, okay? So basically this, we take care of, okay? So this theorem, okay, we incorporate the initial estimates and information about the accuracy of the source of the survey. Right? So basically we're going to use this information that we have on the probability, okay, and then we're going to use this to make a revision on that estimate, okay, based on the information. So basically in a nutshell, it means that we're gonna have to compute those probabilities using the Bayes theorem. And this is important because if you get this property wrong, then the whole calculation is wrong, and you're in big trouble because it starts from this side, right? Because this show up here, you compute the EMV here, if you get this EMV wrong, this will be wrong, 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 wrong. And that's not a good sign, right? When you do the problem, you're not gonna like that. Okay. And I'll have a hard time trying to figure out where should I give you the score. Right, so just pay attention and you'll be okay. Okay. All right. So let's see this in action. Okay. So you see that the key thing about this is you understand what that probability that we try to use. Okay. So this way. Okay. So here we go. The number that you put in there, all right, is this probability. Is probably that the market will be favorable given the result of the survey, not the other way around. Okay, so I probably give you this. Okay, so I'll give you this probability survey. So this is a V. Okay, so I'll be positive. Given that the market is good, okay, I'll give you some probability. Okay, and in the book I think it gives you equal to 0.7. Oops, sorry. The pen doesn't stay. Alright. So, I'll probably give you this probability. Okay, I'll give you the probability the survey will be positive given the market is favorable. Okay. So, why can't we use this probability? Why do we have to use the probability that the market is going to be favorable given the survey positive? The answer to that is, we go back to that decision tree again. You can see that when the first thing you branches on the result of the survey, not the status of the market. So this is the given information. Alright, so you give in the result of the survey first, then I'll figure out what is the probability of the market. So it gives you the property of the market given, if I give you the property of the survey given the result of the market, that's not going to be correct, okay, because that's how the flow of our decision tree is going to be. Right? If you understand all the logic behind this, just write it down that what that property I have to put in is has to be given the result of the survey always. Not on the status of the market. Right? So it means that this probability, okay, is unknown. Alright, so this is what you have to compute. Okay. So this is I know that it shows up on the first line, it's probably given to you know. This is what we have to compute. Alright. So what am I going to give you then? Alright, so this is what you try to achieve, right? And if the problem doesn't give you anything, you can assume that the chance that the market will be favorable and unfavorable is the same, equally likely. Unless I specify that, okay, the chance that the market will be favorable is 0.6, 0.4, whatever. So just read the equation. Okay, it's in there. Alright? So I'll specify what's going to be given to you. So let me change the pen color. Oops, where am I? Pen. Oh, it's red. Let me change to blue. So this will be given. Okay. This is start. I'll give this to you. What else am I going to give this to you? I'm also going to give you this information. Okay. Either this one. Okay. One of this will be given. So let's say give you this one, and I'll give you this one, for example. Right. Because if I know 0.7, I know that the other one, okay, this complement has to be, when you add it together, it has to be equal to 1. Right? So the probability the survey will be positive given favorable market is 0.7. So given the same condition, favorable market, Then the complement of positive is negative. Okay, so that has to be 0.3. Same here, if we give you the property of survey negative, given that the market is unfavorable, 0.8. Then its complement, which is survey positive, given UM has to be 0.2. Right. So note, I don't have to give you these 4 probabilities. I probably give you only 2 of them. Right. So I may give you this one, I may give you this one, and you know that, oh, this has to be 0.2, and I can figure out this has to be 0.3. And with this 6 probability, so note at the end when you do this base thing, you need 6 probability. You need these 4 conditional probabilities, and you need these FMUM probabilities. So that's equal to 6 probabilities that you have to fill in. At the least, but that should be to give you enough headache. Okay. I know probably will not give you 3 cases when, oh, maybe the survey result is positive, negative, or neutral. Then you like, oh, Ajahn never taught me this. How could I do it? Okay. But it's not that difficult to understand the concept. But now I'm probably not gonna crush you with that thing. Okay. All right. So once you have this, what are you gonna do? You're gonna follow that branching thing there. So do we have? Hold on. Do we have it written down? No. Okay. I'll write it on the board for you. Okay. So I'll keep this on for a minute.
Oh my god.
So bear with me. I'll try my best with my handwriting. Okay. All right. So you're gonna branch on the market first. Okay. So you're gonna have FM. Oh, maybe I'll use Excel. Hold on. So maybe that's better. My handwriting with this is pretty bad. Okay, this is better. So this is start, right? And then you can branch on, okay, this is going to be probably the market will be favorable, probably the market will be unfavorable, and this is going to be 0.5, right? 0.5. Okay, so that's how we branch it the first time. Okay, so you get these 2 branches, okay? And then, so let's move it up a little bit. And then you have 2 cases, right, which is probably that the market will be the survey, all right, survey positive, given FM, right? So you get this, and in the handout, that's equal to 0.7, correct? So it means that the probability that the survey will be negative, given the favorable market result is going to be equal to 0.3. Okay. Then similarly here, let's change this to unfavorable market. Unfavorable market. Alright, and this is equal to 0.2 and 0.8. Okay, so that's how the branching thing works, and then you use some of the lines so that you see, so you branch it on something like this. Right? And then, oops, it's not supposed to happen. So that's how we used to do it. Okay? So that's. Any questions on this? No, all right. Well, this is the in addition what you want to do. So then we have to figure out that probability that we talk about, right? This 0.78. So we want that probably is favorable market, okay, given the positive result of the survey. So we want to find out P. Okay, so let me copy this. So this is what we want to find out. First thing. Okay, so this will be equal to what? Right. So this will be equal to this, right? Favorable market first, right? And survey positive is this one, right? So 0.5 times 0.7. Okay, divide by itself, 0.5, 0.7 plus. Then we do the 0.5 here, right? This blue. And positive is 0.2. Okay, and that should give you equal to 0.78. Is it? Yep. Okay. So that's equal to, should be equal to 0.78. So that given, then probably given the same thing, that should be equal to 1 subtract 0.78 equal to 0.2. Same thing for the other one. Okay. Copy this. Okay, I'm going to change this to now the survey result is negative. Okay. Change this to negative. Okay. So when this is negative, we're going to use this red one and this one first, right? Favorable. Negative, so 0.5 times 0.3 divided by 0.5 times 0.3. Now negative 0.5 times negative is 0.8. And that should give you 0.23 then. And this should be equal to, so you see that's not that simple when you do this in Excel, not that difficult. That should be your answer. So you see, it should be quick if you know what to do. Okay. I'll send you this in the email also. Might be work. Okay, and with the homework solution. That's my desktop. Okay, so this is page. It should be easier than I try to write it. Any questions on this one? Everyone's clear? You did this before in the homework and in class exercise also. So basically we just can apply it here. So it's just extra step. So this is, I'll give you one extra thing. Oh, let's say that I'm mean. Okay, let's say I'm very mean. So let's say I give you one more condition. Say I change this to 0.545. 3. Okay, so let's say that there are 3 possible results of the survey. Okay, and I might give you this is the worst case scenario. And probably of extremely good market. Okay, e.g. extremely good. I'll just have whatever rate. 0.2, 0.4. Should be very high. Alright. So let's say you have something like this. So you know how to apply it. I'm just gonna write you what you want. Okay, so let's say you have something like this. Okay, so just basically give you one more condition. So at the start, you have three things that can happen, right? Favor, unfavorable, and extremely good, and you have three results of the survey. Okay, so we want to compute. Let's say probably that the market is going to be extremely good. Okay, given that the survey is neutral, for example. Okay. So we follow the same concept, except we just add more, right? So it should be equal to 0.5, right? This probability. So I'm just going to highlight that. And neutral 0.2. I'm just going to highlight every neutral. And then it's going to be just this probability. So it's not difficult at all. So it should be 0.5 times 0.2, right? Divide by itself, 0.5 times 0.2 plus. Next, I have to do it for FM. So FM is